This is our last video for the chapter, and in this video we're going to take a look at how to solve exponential equations that involve our natural number e. So if you take a look at all four examples, you're going to see our natural number e in them. And again, they're exponential equations, they're not logarithmic equations. So we're going to approach these in the same manner that we solved exponential equations in our last section. So if you can remember back to our last section, we always took our exponential equation, we took the log of both sides. But we can't do that until our exponential part, the e with the x as the exponent with the variable in our exponent, we need to isolate this. So let's go ahead and isolate it, get it all by itself by subtracting our 2. And when we subtract our 2 from both sides, we get 4e to the 2x equals 14. Now we should divide both sides by 4. And when we do that, we get e to the 2x equals, let's see, we can simplify that fraction to 7/2. Alright, so now I want you to take a look at this e here. Whenever you have an exponential equation with e, you can take the log of both sides, like the common log, but it's better to take the natural log of both sides. So let's go ahead and take the natural log of both sides, and I'll show you why. The natural log of e to the 2x equals the natural log of 7/2. So let's go ahead and use our power property of logarithms to move our exponent to the front so that we can solve for it. ln of e equals the natural log of 7/2. I want you to notice here, ln of e, and I'm going to write this up here, ln of e equals log base e of e. And let's ask ourselves, what power do we raise e to get e? We raise it to the first power. So this actually equals 1. So ln of e basically goes away. So let's go ahead and set 2x equal to the natural log of 7/2. And when we divide by 2, that's the same as multiplying by a quarter. Okay, so, or by a half, I'm sorry. So we have ln of 7/2 dividing by 2, or you can have the multiply by a half, and that equals x. So there's our answer here. This is going to be a positive number. Alrighty, so let's take a look at this equation right here. Our exponential part, the part that has our variable in the exponent, is already isolated. So let's go ahead and take the natural log of both sides because we are using the natural number. That is the natural number. We have x minus 2 equals the natural log of 12. And again, we're going to take our exponent, we're going to move it to the front by using our power property. And because it's complex, it's a binomial, we need to put that in parentheses. Natural log of e equals the natural log of 12. Again, the natural log of e is log base e of e, and we can simplify that because e to the first power is e, so the natural log of e is just 1. So we get x minus 2 equals the natural log of 12. So in order to solve, all we have to do is add 2 to both sides, so we get 2 plus the natural log of 12, and that is our final answer. Okay, let's go ahead and solve this one. Our exponential part is not isolated. We have a 2 in front, so we're going to divide both sides by 2, and we get e to the negative x equals 20 divided by 2 is 10. So we're going to go ahead and take the natural log of both sides because we have this natural number here, and that equals the natural log of 10. We're going to take our exponent, we're going to move it in front, so we get negative x. The natural log of e equals the natural log of 10. So now this is going to basically cancel because that is the number 1. We get negative x equals the natural log of 10. And when we solve for x, we get x equals negative natural log of 10. Oh, I almost forgot the negative. There we go. Last example here. All right, the exponential part is not isolated. We need to get rid of this plus 5, so let's move it over. We have e to the 3x. When we subtract 5 from both sides, 15 minus 5 is 10. Because we're using the natural number, we are going to use the natural log to get rid of it. So we have the natural log of e to the 3x equals the natural log of 10. We're going to take our exponent, and using the power property, we're moving it in front. We have 3x. The natural log of e equals the natural log of 10. That cancels, and we have 3x equals the natural log of 10. And our final answer is going to be the natural log of 10 all over, not just the 10, but the whole natural log of 10 is going to be divided by 3. And that is our final answer. That is how you solve exponential equations that involve our natural number as our base.